Okay, so we got a subtraction problem here. I would copy out of the book because it's sometimes hard to read off here. I'm always assuming when you're watching the videos that you're looking at your book, and that's where you write the question down from. If I'm looking at this and I want to get a common denominator, these look almost the same. What's the only difference in them? Yeah, it's like they're flipped, and that's like they're subtracted. If they were added, it'd be really easy to just flip the order of them, right? And it would. But there, do you remember that there is a way to flip the order of something when it's subtracted? What I can do is this. Let me look down at the bottom. If I have two things and they're subtracted and they look like something else, I want to make something like that second denominator look like the first denominator, I could factor out a negative. I could say, let me divide a negative out of these. What is 3y divided by a negative 1, for instance? If I factor out a negative, it's like dividing by negative 1. 3y divided by negative 1, wouldn't that be a negative 3y? Multiplying or dividing by negative, just change by negative 1, just changes the sign on something. So minus 2x or negative 2x divide out negative 1 would be a plus 2x. The good thing about that is now those two numbers are added, aren't they? And when I add two numbers, if I'm looking down at that second denominator, when I add two numbers, I can just switch the order of them because the commutative property says it's okay to do that, doesn't it?
I think you're missing a 3 on the one that problem before. On the 2x.
Thanks, thank you. Thanks, yeah, copying down is my biggest challenge. That's a minus there, okay. So if you look at it, this 2x plus negative 3y, that's the same thing as, let me just put a line through there. Isn't that the same thing as 2x minus 3y here? Adding a negative is the same thing as subtracting. It's just a definition some mathematician made. They got tired of writing plus and minus all the time. All right. Now, here's the deal. You got 6 over 2x minus 3y minus 3 over a negative 2x minus 3y. This negative, I could write it down here. I could have just have easily have written it up here equal with the fraction bar if I wanted to, okay? So, in other words, this is subtracting a negative fraction. When you subtract a negative, doesn't that become a positive, right? Minus a minus becomes a positive. If that bothers you, if you were to move that negative up here, what you can do is make it positive down here, make it negative up there, you could see it a little bit better. Two negatives make a positive, and then my second fraction, if I got rid of that, if I moved that negative so that it was easier to see, what I've got on the bottom now is 2x minus 3y. When you add two fractions, you keep the same denominator. You got to have a common denominator, and we have it now. And on the top, what's 6 plus 3? 9. Okay, and that's all there is to that one. Okay, so I've got, like on number 27, they're actually adding something and then subtracting from it. The thing about it is, if I had three fractions, back in elementary, junior high, if you had 1 over 7 plus 2 over 7 plus 3 over 7, you would just keep the same denominator and just add across the top, right? So I still, even if I've got three things, they've got to have a common denominator, or I can't really add them together. So the thing about this one is, what's my common denominator going to be? What's the only denominator you have? Yeah, it's this right here. So that means your x needs to get multiplied by x minus 3 over x minus 3. And your 2 needs to get multiplied by x minus 3 over x minus 3. And then I've got the whole minus x squared plus x minus 6. And here's the thing about this. If you look at how it's written in the book, that whole fraction is being subtracted, right? Let me go ahead and do this. I'll tell you what, on this step, I'll just write it down the way it is. That does not mean that it's a minus x squared. You got to subtract every single one of those terms in the numerator is what I'm trying to get at and not saying very eloquently here. We'll do that in the next step. Okay, so now I've got my common denominator. It's x minus 3, but don't I have a whole lot on top to combine, right? Is I keep my common denominator, and then I just either add or subtract across the top. But before I can even do that, I've got some distributing to do here, don't I? X times x is x squared. X times negative 3 is negative 3x. Then I come to the second term. It's a positive 2 times x, so that's a plus 2x. And then a positive 2 times a negative 3 would be a minus 6. Now here's where it gets, you gotta really be careful. This subtraction sign went with that whole fraction, so I gotta apply the subtraction sign to each term in the numerator. I gotta say that's a subtract my x squared and subtract my x, and then a minus 6 becomes a plus 6, and I need to extend my fraction bar there. Okay, we're almost done with this one. X minus 3 is on the bottom, and on the top, let's combine like terms. Here's a x squared, but here's a minus x squared, so don't they cancel out? I'll just mark them out. I'll use some different colors. Here's a minus 3x and a plus 2x, so a minus 3x and a plus 2x would be like a minus x if I combine them, right? And then I got another minus x, so a minus x minus another x would be a minus 2x. Let me write that up here in black. So that took care of this term, and this term. Now what about the numbers? I see a minus 6 and a plus 6. What are those going to add up to? 0. So my answer is just minus 2x over x minus 3. Okay, so we just have been talking about how maybe it would be good to reduce first. So here's the deal. I am going to need to factor, because I notice on the top I have an x minus y, and this x squared minus y squared, isn't that a difference of two squares? It's something squared minus another thing squared. So if you remember how you factor it, you'd have an x in the two first spots and a y in the two second spots in the factors, and then you need one plus and one minus. But look up here. Isn't there an x minus y there? Couldn't I cancel that one out and that one out? Again, I would want to do that first, because if I don't, I'm going to have something worse to factor in the end, and we don't want anything worse to factor. We'd like to keep it simple if we could, right? It's always best to keep things simple. All right, so here's what I end up with. If I notice those two things cancel out, I've got 1 over x plus y, and then 1 over 2x plus 3y. Okay, let me put my little parentheses around them just so I'm thinking those things go together. It's a y. So doesn't the first, if you look at these, can I factor out anything of 2x plus 3y to just have an x plus y over there? Sometimes if it had been 2x plus 2y, we could have just factored a 2 out. It would have been a whole lot easier to make that common denominator. It just doesn't work here, does it? So the first fraction, the 1 over the x plus y, if I'm thinking about a common denominator, it's going to need this right here to get the common denominator. So it's going to be 2x plus 3y. And if I do it to the bottom, I got to do it to the top, right? And then the second fraction over there, the 1 over 2x plus 3y, what is it going to need to have the same denominator? Yeah, it's going to need this x plus y over here, so you got to multiply the bottom by x plus y and the top by x plus y. Both of them, numerator and the denominator. I'm going to try to kind of go over here and work, just because if there is no way my memory is going to help me. I'm never going to remember that to copy it on a fresh slide. Do you agree with me that now I got a common denominator? It's just x plus y times 2x plus 3y. You might want to write it the other way. It doesn't matter what order you put those two factors in. On the first fraction, at least it's a 1 times 2x plus 3y up here on the top. Isn't that just going to be 2x plus 3y? And then, yay, I'm adding, so at least adding is always easier than subtracting. If I have a 1, if I have 1 times x plus y, isn't that just going to be x plus y over here? So this one's not going to be too bad just because we had those 1s on top. You love it when you have numbers on top, especially 1s, because it makes it so much easier when you're multiplying stuff out. So my common denominator, I'm just keeping up with it, it's x plus y times 2x plus 3y. But if I combine like terms, I got a 2x here plus another x here. That adds up to 3x, right? And then I got some y's I need to add together. I got a 3y and plus another y. Isn't that 4y? Okay, I'm finished at that point. Again, 31 can be easy to mess up because there's two subtraction signs, so we got to be careful. Now, even though they got two of them in a parentheses together, I could go ahead and get a common denominator for everything, because isn't this x squared minus 1 up here? Isn't this a difference of two squares? It's supposed to be circled in red, and it's not, but isn't that a difference of two squares? X squared minus 1, wouldn't that factor into x minus 1, x plus 1? And don't I see those other factors on the bottom of those fractions there? So my common denominator here is actually going to be this x squared minus 1, because x squared minus 1 does factor into x plus 1, x minus 1. I don't want to go multiply everything by everything else when there's something smaller. It's kind of like if I have 4 and 6 as a denominator and I'm adding two fractions, when the smallest thing, I could pick a 12 to be that denominator, right? I could also pick 24. I could multiply them together and get 24, but the 12 is so much smaller, and especially in these kind of things, I want to go for smaller. So what I'm going to do is this. I'm going to say, okay, 1 over x plus 1, what would it need to get the x squared minus 1? What is it missing? If this is my common, it's an x minus 1, right? Yep. So it needs an x minus 1 to get x squared minus 1 on the bottom, because again, this is my common denominator over here. Now I'm going to put my subtraction sign down. My 1 over x minus 1, notice I'm adding in parentheses just because they're really helpful for your brain, I think, to think. What does that x minus 1 need to have this common denominator over here? Yeah, I need the x plus 1, so we'll multiply the bottom by x plus 1 and the top by x plus 1. This is tedious, but isn't it the same thing you do when you do fractions with just numbers in them? You might not like it, but it's the same concept. It's just got a lot more unknowns in it. Do I need to multiply this one that has x squared minus 1? Do I need to multiply it by anything? No, because it's already got the common denominator. The common denominator is x squared minus 1. I just had to go give those other denominators what they were missing in order to make x squared minus 1. Okay. Let's work. Let me go ahead and, we know we got to work in the parentheses first, but I can simplify each fraction as I go. For instance, the very first one, let's see, 1 times x minus 1, isn't that just going to be x minus 1 over x squared minus 1, right? This right here is just this right here. Now let me put my subtraction sign and let's look in the parentheses. Isn't 1 times x plus 1 on top? And on the bottom, don't I have x squared minus 1? Isn't that what I created when I took x minus 1 and multiplied it by x plus 1? Again, this is all getting back to factoring, isn't it? Recognizing that what I was missing was part of a difference of two squares pattern here. And then I got 1 over x squared minus 1. I need to work in the parentheses first, so that's what we'll do. Again, I'm putting lots of intermediate steps in here that some of you might wish you could skip. So on the bottom, inside the parentheses, I've got a common denominator. Let me write it, and let me just combine the two fractions. When I subtract fractions, I always take the first one, and I subtract the second one, so it's x plus 1 minus 1. Isn't x plus 1 minus 1, though, inside that parentheses in the top? Isn't that just going to be x? Because isn't 1 minus 1 0? Okay, so we just got x over x squared minus 1. Okay. Okay, so now I'm down to two fractions that I'm subtracting. Do I have a common denominator? Yep, so let me just write it with the common denominator. And it's the first fraction numerator, which is just this x minus 1, and then I'm going to subtract x. What's going to happen on the top? We got an x minus x. Those are going to cancel out, aren't they? Right? And then all I'd have left is a minus 1 on top over x squared minus 1.